Hello everybody, welcome back. Let's keep moving. We're doing week 3, number 4, longest substring without repeating characters. Given a string S, find the length of the longest substring without repeating characters. So example 1, you have this type of string, ABC, AB, C, B, B, and the longest substring, I guess they're talking about contiguous substring, is ABC with length of 3. And how do we know that? The longest substring is ABC with length of 3. I think that's this right here, right? ABC. Okay. ABC with length of 3. Is there a longer one? Could this be ABCA? No, because this one would be a duplicate, right? So if there was an ABCA, you'd have to delete this A, and then now you're back to BCA. So I guess this is also a longest substring. Still the same length of 3, but it's also still long. Could it be BCAB? Could you add this one here? You could not, because you'd have to delete this one right here. But this one's also a length 3 substring, CAB. Okay, cool. And then could you extend it out to C? No, you could not, because that would have to, you have to delete this C. So there's actually many substrings of 3. So there's ABC, there's CAB, there's BCA, and then CAB, and then I guess ABC again. And then could you extend it here? No, because this one is a B. You'd have to cross this out, and then now you're only at 2. And then could you add this B, this one right here, could you add this B? Well, you could not, because it already has a B right here. So you'd have to get rid of this one, which by default gets rid of this one, so that would be only a substring of 1. Okay, and then the second example, I guess, kind of makes that point again. The second example is, what if you had B, 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 and B? Well, you get a substring of 1 here, and you want to think, like, can I add this one? I cannot, because that's a duplicate, so I'd have to cross that out in order to add it. Now you're at a single substring. Can I add this one? Cannot, because it would be a duplicate. You have to delete it to add it. And it's, a similar process. Okay, let's do the last example. Example number 3 is PWWKEW. So the answer is WKE with a length of 3. Okay, so let's just do it ourselves and figure out why it's a length of 3. You start with 1, substring of 1. Great. So you want to wonder, can I add this substring? Well, how do I know? Like, what's going to let me know? Well, I want to at least have some type of, let's call it a set, right? P. And if this W is in this set, then I know I can't add it, right? So this W is not in the set, right? So I can add it. Is this W in the set, right? Or I have to add this first W into the set. Is this second W in the set? It is in the set. Okay, so that's bad. Because it's in the set, I have to get rid of it. Or I have to delete that W. But that actually deletes the P, right? Because I can't make a string that has 2 blocks that are not contiguous, right? It has to be contiguous. So that means I'm getting rid of this W, this P as well. So now I'm stuck with a string with only 1 element, right? And now I have a set of only 1 element as well, this W. What about this K? Can I add this K? Well, the K is not in the set, so I can add that to the set, extend the list. What about this E? Can I add this E to the set? Well, it's also not in the set, so I can add this to the set, extend the list. And this, if you look at it, it's actually a substring of length 3, right? So this is larger than any substring we've seen, make sure we save that into some, results variable of maximum substring. And can I add the W here? It's in here in the set, so I cannot add a W. And unless I go ahead and delete that W, right, then I can add the W. So now KEW is something with the longest substring without repeating characters, right? KEW. So actually this answer has, this example, number 3, actually has 2 answers, right? WKE with a length of 3. Notice that the answer must be a substring. PWKE is a subsequence, not a substring. But KEW is also, KEW should also be an answer to that, right? Let's see if that works here. KEW. So let's just see if that works. So we want to see if this the point of this problem is this to return the first longest substring, or is this to return any longest substring, right? So, oh, sorry, you're just returning the length of it, so it's just returning 3. Okay, so it's just any longest substring is fine. Okay, that makes a lot more sense. So let's look through this, and from what we have diagrammed out here, can we derive the code from this? So one thing that we need to do, at least, is to be able to iterate through the string, right? So we need some for loop that iterates through the string and has a concept of a current element, right? Another thing we need to think of through is like, how do we structure this memory aspect, right? If we have a set, we know what to delete, but how many of it to delete, right? So the example that we saw that was perfect was right here. It's kind of hard to see now, so let me go ahead and I just write it again. But imagine I had this example, right? I had A, B, C, and the next thing that I want to add here is actually a B, right? So the most convenient one would be an A, right? I have a substring of 3. I see an A. Go ahead and delete this A. Now my substring is still 3. But if it's A, B, C, B, I have a substring of 3. Considering adding this B, but I can't. I have to delete that B. But because I deleted that B, I'm basically deleting this A as well, right? So I'm down to a substring of 2, of length 2, right? So if I have a set, right, I don't have a concept of ordering. I don't know which one I have to delete. So in a way, I have to delete up until some number, and it's possible that I would need to put that onto a stack, right? So for a stack, I would go ahead and take this A, put that on a stack, or let's just move the stack over here. An A, a B, a C, and once I encounter a B, this B has an intersection with my set, or my stack, and I basically need to pop off these elements until I just have, right, that C goes away, this B goes away. I've popped off the elements. Actually, a stack is not the right data structure here, because I don't need last in, first out. I need first in, first out, right? I actually need this A to be here, this B to be here, this C to be here, and then I need to pop until the B is gone. Ah, interesting. So it's not really a stack, because it's first in, first out, right? It's more of a queue. So the A's gone, the B's gone, and now I can put the B back on, and this B would actually be on the bottom in the queue. I should not have drawn these boxes, because these boxes or trays kind of naturally look like a stack. But importantly, I would need some type of first in, first out mechanism for this. Okay. Let's see what else we need, if we need anything else. All right, so I need this FIFO mechanism. So what is FIFO? Well, a list is FIFO, right? If you have a regular list and you iterate through it, right? This is first in. This would be 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 first in. So I guess I can iterate over a list as well. So, you know, it seems like what could be helpful is actually knowing the bounds between, you know, the bounds of this list in general, right? So if I have the bounds of this and I reach this B, then I can basically do a FIFO iteration by going and iterating. I guess this is called a pointer. I guess I can call this a left pointer and a right pointer, right? This is the left pointer and the right pointer of the bounds of this window, right? I guess in a way this is a sliding window problem. Didn't really think about that. So we have this window, we have this left and right, and I'm moving this right, and the right, when it finds this new element, we need to check the validity of the condition, right? So the condition is valid if the right element, let's call it, go ahead and delete these things, is not in, you know, this memory that we have here. Just not in the, I'm just going to call it the memory, right? Not in the memory, right? So I guess we could just move the pointer up, and if the right's still in the memory here, and we know that it is because this is a B and this is another B, we can move it up again. The right's not right. If the right's still in the memory there, then we can keep moving it. But this, in this case, it's not. So we are in a valid state, right? So, you know, if we had to write this code, it would be initializing these, called left and right pointer, right? And we're basically going to start considering, so while right is smaller than the length of the string, we're going to do a consideration step, right? A consideration is, let's say it's a maybe. So the maybe equals the string at this right pointer, right? And then if the maybe is not in memory, then we're in a good state, right? If it's not in memory, then we just keep going, right? If it's not in memory, we possibly update that results variable that we have, and then you know, move right +1, right? We move right. Else, if it is in memory, we want to move left and take it out of memory, right? So memory delete at left, right? Whatever's at left, and then we move left up, right? So we move left +1, right? Move left +1. And I will take this as a perfect example here. So in the beginning, L and R start, you know, at 0. And go ahead and say this is the memory right here. Right? L and R start at 0. So it's a consideration, right? Is A inside of our memory? Well, our memory is empty, so it's not. If A is not inside of our memory, we're going to update the result, right? And the result is going to be our target, the longest substring, right? So the result's going to be the length of this current string, and the current string is, you know, well, 0, and now it's 1. So it's going to be result plus 1, right? And we got to remember to do it here too. Update result by -1. Okay, so we put A in memory, right? And that is put A in memory. So memory add whatever's at the right pointer. Perfect. So we put A into memory, and then we move the right pointer, and B. So B is now up for consideration, right? And is B in memory? Well, we know it's not, right? So the result goes from 1 to 2. B goes into memory, and the right pointer goes up. C in memory? C is not. So we put C in memory. Result is now 3, and we're fine. So, in yellow here, we updated the result. We are going to add it to memory, and then we're going to move right 1 position, right? So then we move right to B. Is B in memory? Well, B is in memory. B's right here. That's bad, right? So if B is in memory, we're at this block of code. Then what we need to do is delete whatever is at left, right? Delete that, right? We want to make results 1 smaller, and we're going to move left, right? Is B still in memory, right? So instead of an else here, we'll probably have to put a while here. So like while it's in memory, right? So while whatever's at right is in memory, we do this thing. And maybe we'll switch these because maybe they'll be at top. But while it's at memory, we're going to keep doing this kick out process, right? So here L is here, B is going to be kicked out, and then we move L, right? Results has gone back to 1, and now we're in this case. So in this case, everything looks fine, and because we have the while, we're actually going to revisit this, right? So we're going to revisit this. We're going to update the result, so +1. We're going to add this new B into memory. So this is a new B. This is not that B. We're going to add a B into memory. So in memory is now C and B. And then, we can move the right into this empty space, and that's going to end our iteration. And that's the code. Hopefully that made some sense. But that's the code we're going to write. And I believe it's going to make a lot more sense once we look at the code over here. So this is from the thing that I added. Okay. So we're going to start left is equal to 0. We're going to start right equal to 0. And I'm going to move this left here and then move this right here. It's going to start at 0, right? So while we should continue doing this is when the length is when the right is smaller than the length, right? So we want to continue this right to go from here to the B to the C to the B again, but not we don't want to continue the while loop while we're outside of there. Okay, so what letter are we going to take into consideration? So new letter is going to be S at this right? And we want to, there's 2 blocks here, and I'm just going to change the colors completely. So this one's going to be blue, and this one's going to be green. All right, so there's 2 blocks here, and maybe the while loop, this arrow here should go first, right? So So if we probably still need this if statement. So if this new letter is in memory, well, we don't have memory because we haven't made it yet. So let's make a memory here. Memory is, let's call it letters seen, or letters, you know, in current substring, right? Letters in substring. So that's going to be a set. So if the new letter is not in this letters in substring, then should we do not in or in? I guess we can do in, right? Because we want to do the while loop first. So if it's in, we have to basically eject from memory the left substring, right? And what that's going to do is like while new letter in memory, we're going to eject it. And what does ejecting mean? Ejecting means remove from memory. That's what ejecting is. And then we're going to do left, you know, we're going to move left, right? So we're going to move the left pointer. And then I guess that's it. Yeah, I guess we don't need to do anything here. So at this stage, we're at a valid state. So here we're valid. And what does valid mean? Valid means we do whatever's in blue, right? Or to make it more clear, we'll do whatever's in gold. Right. And so we want to, what's in gold here? We want to do results plus equals 1. We don't even have a results. So let's keep our results here. So let's say results start at 0, or length of substring is 0. And then we want to add 2 letters in substring, right? So this new letter, or letters in substring, we're going to add the new letter. And I guess we also need a max here. So we need some type of max length seen. And we'll go ahead and make that 0, I guess. So we add a new letter. And I guess if we have these pointers, we don't need to keep a length of the substring. We could just, so the length of the substring will be right minus left plus 1, right? So if you have a letter, if you had something like this, it's going to be that. And imagine you wanted the B and the D, right? The B and the D is B, C, D, and the indices will be 3 and 1. So 3 minus 1 will be 2, but you want to add 1. So this would be a length of 3 substring. So I guess we already have that. So I guess at any point here, you can say max length seen is the max of whatever the max length seen was before, and then this calculation of what is the current length of the substring based on what we have. And then this actually allows us to not have to do this tracking. Okay, so if it's valid, you want to add the letter to the memory. You want to do the update, right? So update results. So this stage is valid. this stage is invalid. We want to add to memory. We want to update results, and then we want to move right. Right, so right equals right plus 1. At the end of this, we want to return max length seen. Now, this function is not finished yet. I kind of hand waved and pseudocoded parts of it in order for me to keep moving. But if I just close this code, you could see that this is what we need, right? So I'm going to fold this just for now. But you could see that if it's invalid, we want to set it back to valid. So whatever's in this code block is setting it back to valid. Once it's valid, we want to do our steps, right? We want to add it to memory. All right, that's step 1. We want to update some results, right? And the result is max length seen. And then we want to move our pointer, right? So then we can continue this iteration. And that's this part, right? So I'm going to make this red. We want to move our pointer, right? We want to move this R until there's nothing else to look at, right? And in the best case, you have, completely unique letters, and the R is just moved all the way down, and the left doesn't have to move at all. And the reason the left doesn't have to move is because every letter is unique, and there's no reason to make the window smaller if you already have a valid larger substring, right? All right, so let's work on fixing the invalidity, right? Okay, so we want to eject something from memory, and so while this new letter, right, it actually should be in, so this is a bug here. It needs to be, it's not is, it should be in, right? So while this new letter is in letters in substring, then I want to kick out something, and I'm kicking out the left pointer, right? So letters in substring dot remove, and what's at the left pointer? At left pointer is, how do we get here? Is s at left, right? So we want to remove whatever's at the left pointer, and then we want left to move a single step, right? So I'm going to do this fast. I'm going to do this one more time, and I'm going to do it fast. There's A, B, C, B. We have a left pointer, we have a right pointer, and in the beginning, it won't be invalid. It'll be valid. So stage valid will have an A, and that's going to be added to memory. We're going to update maxine. Maxine will be 0 minus 0 plus 1. So maxine is going to be 1. And then we move the right pointer. And here, we're going to be valid again. So we're going to put that B in there. Maxine is going to be updated to 2. And then we're going to move this again. We're going to put that C in there. This is going to be updated to 3. We're going to go again. We're going to put that B in there, or we're going to consider it. Now we're in an invalid state, right? Now it is all reds. So what are we going to do at this point? Well, at this point, we want to continue to do something until it's valid. And what that means is kicking stuff out, right? So this L right here is going to be kicked out. Whatever's at the L. So the A is at the L. Boom, right? Now this letter in consideration is still invalid, right? So we're going to move the left pointer. See this B here? We're going to kick this out. This is still invalid. We're going to move the left pointer again. There's a C here. Well, nothing needs to be kicked out, right? This substring is now valid. So this is, green. All the while, maxine has been updated to 3, right? And we only need to update Maxine when it's valid. We don't need to update it when it's invalid because that means the substring is getting smaller, right? There's no need to do that. All right, let's see if we got some cases. Maybe there's a case we haven't looked at. It's quite possible. These cases are very comprehensive. All right. 97%. This is a big swing. Remember, the actual number here doesn't matter. You have to understand your time complexity. So what is our time complexity? Well, we have a string, and we have a left pointer and a right pointer, and the left pointer and the right pointer only go forward. So at max, the left pointer and the right pointer can go O of n for both of them, right? 2 times O of n, that's going to go ahead and be O of n, right? We're going to get rid of that constant multiplier. And that's it, really. I mean, we build this memory and we delete it. That's also linear. So this is O of n runtime. And how much memory do we need? Well, this letters and substring set could potentially hold the entire string. So we also need O of n memory. Now, I guess we could do this without extra memory if we just kept looking through the string, right? Because the string already holds the information. You just keep looking through the string. But that's not going to be the right way to solve this. Thanks a lot. I hope you got everything you needed from the explanation that we had. I think the intuition is pretty clear if you think about how your brain goes through this. It's probably hard to do the whole intuition when you're looking at examples that are so small, because you can kind of just figure it out. But you can think of an example that is, quite large. And now you really do need that, right? Now you need some form of going through each one and maybe it's that one. I'm unsure. So if you find that the examples don't give you an intuition, make the examples super large. Then you really do need some type of data structure or something to help you figure out the problem. All right, thanks a lot. I'll see you guys again in a little bit. I'm going to keep plowing through week 3, and I'll see you next time.